Hello everyone, welcome you all in the M.Sc second year organic chemistry. Hope you are all safe and healthy at home. So due to this COVID-19 situation, our college has started a online lectures for all the undergraduate and postgraduate students. So today we will be take a overlook for a syllabus for M.Sc second organic chemistry, and especially for the subject we will be discussing upcoming lectures. So we know that the choice-based credit system was introduced in the M.Sc syllabus in 2013 and it is revised in 2019 for M.Sc first year and from the current year 2020 for the M.Sc second year. So we know that this is a choice-based credit system, and in that credit system you have given credits and you have to earn the credits, and if we earn the credits you will be qualified. In M.Sc second year there are two semesters, semester third and semester fourth, because the semester first and second in the M.Sc first year, and in M.Sc second year, the semester third, there are 4 theory courses and 1 practical course. Theory course, that is CCTP 7, whose code is CHO 350 and the name is Organic Reaction Mechanism and Biogenesis. So this course is for 4 credits. Similarly, the course CCTP 8, whose course code is CHO 351. It is structure determination of organic compounds by spectroscopic method, with a different spectroscopic method, that is H1NMR spectroscopy, C13, and some other, that is phosphorus, and other technique is there. Then there is a mass spectrometry is also there. Then the theory course 9, that is CCTP 9, whose course code is 352, CHO 352. It is stereochemistry and asymmetric synthesis of organic compound. The stereochemistry for the various cyclic system, 6-member, 5-member, 4-member, or small size ring, medium size ring, and large size rings, and also their fuse bridge systems are there. The course CBOP 3, it is an optional course. There are 2 options are given, and among these we have to choose one option. It is CHO 353 theory course. Here option A is protection, deprotection, chiron approach and carbohydrate chemistry is there, and section B or CHO 353B is designing organic synthesis and heterocyclic chemistry. So among these 2 options we will be discuss option B, that is designing organic synthesis and heterocyclic chemistry, because in the designing organic synthesis, so this is we can say a summary of the all organic chemistry, because we will discuss here many types of reaction, name reaction, some oxidizing reducing agents, and many of the reactions, because so this is very important topic, and therefore we will discuss this section, that is designing organic synthesis and heterocyclic chemistry. Then CCPP is a practical course, CHO 354. It is solvent free organic synthesis. You have to perform the reactions without solvent, as like green chemistry. Then semester 4, there are 3 theory courses and 2 practical courses. CCTPT 10, it is a 10th theory course, that is CHO 450 chemistry of natural product. It is again for 4 credits. CCTP 11 theory course 11, it is CHO 451 organometallics reagents in organic synthesis. CBOP, it is again optional course, CHO 452, that is theory course. There are 2 options are given, one is medicinal chemistry and second one is a applied organic chemistry. Then CBOP is a practical course, CHO 453. There are 2 sections are there, 3 sections are there. and among these three you have to choose any two. Section 1 is ternary mixture separation. Section B is carbohydrate synthesis and isolation of natural product. Section 3 is project, industrial training, internship or summer project, right? So among these three sections you have to choose any two sections which is for the 4 grades, right? And the last practical course is CCPP, practical course 4. It is CHO 454 and it is a convergent and divergent organic synthesis. So here are multi-step synthesis, some single step synthesis are there, and so this is the total overview of your syllabus in M.Sc second organic chemistry. So among these, so today onwards we will be discuss on a CBOP, that is optional course 3rd, CHO 353, and option B we are choosing here, that is designing organic synthesis and heterocyclic chemistry, because we already told that in designing organic synthesis we can take a summary of all organic chemistry. Here we can study name reaction, oxidizing reducing agent, some transition reactions, some heterocyclic reaction, some pericyclic reactions and so on. So this course is for 4 credits. It is divided into 48 lectures plus 12 tutorials. So that means this 12 tutorial is for continuous assessment, that is called as internal mark system, that is internal examination, and 48 lectures is for external examination, right? So these having 2 sections, 22 lectures for section 1, 22 lectures for section 2. Section 1 is designing organic synthesis, which is divided into 24 lectures and 6 tutorials, and section 2 is heterocyclic chemistry, 22 lectures and 6 tutorials. So this section 1 having 2 topics. One is concept of retrosynthesis. Concept of retrosynthesis, in this topic we have to discuss what is retrosynthesis, what are the rules in retrosynthesis, it is retrosynthesis analysis. Here we have to discuss disconnection approach. Here we have to study some basic rules while disconnecting the molecule. Retrosynthesis is the opposite of synthesis. That means in synthesis we will add some reagent and we give some products, right? But in retrosynthesis some target molecules are there, some molecules are there, and we have to try to disconnect this molecule in such a way that it can be convert it into a small fragments which are easily available, whose cost is low and which can be easily used for the synthesis of given target molecule. So we have to discuss disconnection approach. Here we have to discuss some basic concepts, that is what is meant by target molecule, what is meant by disconnection, what is meant by functional group interconversion, then what is meant by synthose, what is synthetic equivalence. So these different concepts we have to discuss. Then multi-step synthesis, multiple synthesis, that means for the given target molecule there are different steps are available, or we can say different synthetic routes are available, and we have to choose a best route for the synthesis. Then functional group interconversion, illogical 2-group disconnection. So sometimes when we are disconnecting the molecule, so generally we get a logical synthose, or we can say a logical group disconnection. Logical means, that means we know that oxygen having negative charge is the logical. Then we know that carbocation, carbanion. So these are the logical synthose. But in some molecules we have to discuss some illogical synthose. Illogical synthose means oxygen carries positive charge, right? Then the carbon near to the electronegative atom is electropositive. So that means illogical 2-group disconnection, or it is also called as a we can say that reversal of polarity. So that we have to discuss in this topic. Then we have to discuss carbon-carbon disconnection. Carbon-carbon disconnection, that means if the number of carbons are present in the molecule, then we can disconnect carbon-carbon molecule. Donor and acceptor synthons, that is logical and illogical synthons. Then we have to discuss two-group disconnection. In a single molecule, suppose there are two groups like hydroxyl group or sometimes it containing carbonyl group. Then we have to discuss how to disconnect such two groups. Then 1,5 related function group disconnection. Here we have to discuss 1,2 disconnection, 1,3 disconnection, 1,4, 1,5 disconnections, 1,6 disconnection. So these are the some molecules we have to discuss. Here again we have to discuss umpolum. Umpolum is again another concept. It is called as a reversal of polarity. So that we have to discuss what is meant by umpolum and what is reversal of polarity will be discussed here. Then conversion synthesis, conversion. Then special methods for small rings. We know that small rings can be synthesized, how it can be synthesized. But here we will discuss some special methods for the synthesis of small rings, heteroatom and heterocyclic compounds, their disconnection, and some problems on the basis of all these topics which are discussed in this topic. So here we can use some references that will be discussed later on. Then second topic in the designing organic synthesis is application of retrosynthetic approaches. Here we will be discuss some big molecules and their retrosynthesis and synthesis. Which are these molecules? That is strychnine, some we can say drugs or some products which are used in the medicinal chemistry. So that molecules we have to discuss, their retrosynthesis and their synthesis process we have to discuss. One is strychnine, second is reserpine, then thionamycin, astelotoxin, then indolozomycin, then erythronolide B. So these are the some molecules, 6 molecules whose retrosynthesis and synthesis we have to discuss. And here this topic is again divided into 12 lectures. That is quite big topic. So there are different synthetic routes are available, different disconnection approaches are also available. So we have to discuss all these groups, right? Then references. So these two topics, that is retrosynthesis and synthesis of some natural products or some drugs, that we have to discuss. For the topic 1, that is retrosynthesis, we can use 3 references, that is Designing Organic Synthesis by Stuart Warren. It is a very best book, reference book. So from that book we can understand the concept of retrosynthesis. Then the second reference is Organic Chemistry from Retrosynthesis to Asymmetric Synthesis by Vitomir Sunjik, that is Springer publication is there. So you can use this. Then for the topic, that is retrosynthesis of some natural products and drugs, you can use a Classics in Total Synthesis by K.C. Nicolo and E.J. Sorensen. So these books is used to understand the retrosynthesis of some natural product, that is strychnine and all these molecules. And there is one additional material there, that is NPTEL lectures, that is a study guide in organic retrosynthesis problem solving approach. So this is a link where you can use the PDF for the understand some basic problems and how to understand some basic problems on this topic. So friends, let us stop here. The actual syllabus we will be starting. Actual syllabus will be start in next lecture. So thank you for watching video. Thank you.